Okay, so when I want to standardize x to my z value, remember we always get given this information that my x follows my normal distribution with my mean and my variance. So now to find the z, I say that my z value equals my x, okay, which is my variable, minus the mean divided by the standard deviation. So I'm always going to take the x value that I've been given, minus the mean, and then divide it by the standard deviation, and that will give me the standard z value that I can then look up on the table and decide which area of the curve that I'm going to look at. Okay, so if we look at some examples of those types of questions to standardize first. Okay, so I have trees in the Redian forest are classified as tall, medium, or short according to their height. The heights can be modeled by a normal distribution with a mean of 40 meters and a standard deviation of 12 meters. Trees with a height of less than 25 meters are classified as short. So now find the probability that a randomly chosen tree is classified as short. So the first information I've got is trees that are less than 25 meters are short. So that means that what I'm looking at is the short tree is that the probability of that x is less than 25 to be short. Okay, so now this is the x value that I'm dealing with. So it's not standardized, okay, because we know it's not standardized because there is no value for 25 on the table. The z values go up to a maximum of 2.9, okay? So to standardize, okay, I'm going to use the x value minus the mean over the standard deviation. So I'm going to say that's going to equal the same as saying the z value now, okay, because I've changed the x to the z, is going to be less than my 25 minus the mean, and the mean is 40. So minus 40 divided by the standard deviation, which is 12. Okay, so now if I put that into my calculator, I get an answer that is negative 1.25. So now I have a standardized z value, and that value I would be able to look up on the table. So now that I've got my z, now I need to figure out on the curve what I'm actually looking for. So first thing I know, it is negative. So it's going to be on this side because it's negative 1.25. And I want everything less than. So everything less than my negative value means it's everything over there to my left. Okay, so now I know that I can't use negative numbers. So the first thing I have to do is flip my curve. So if I'm going to flip the curve over, that's going to become on that side as 1.25, and then everything there is now going to be over there. Okay, so now I know that my number is positive, but it's going to the right. So to get everything to the left, I need to subtract all of that from 1 to get the curve that I want, or the area that I want. So that means I'm going to say 1 minus my phi value of 1.25 that I'm going to look up on the table. So now I'm going to say 1 minus my 1.25. Now I take my table, I find 1.2, and then I find 5, and I find that I'm looking for 0.8944 as my value. So then I say 1 minus 0.8944 to get my final answer of 0.106. Okay, so there is now my probability of my short tree. Okay, so that's all we have to do for our sums. So if I look at another example, so here given the weight of an adult female giraffe has a normal distribution with a mean of 830 kgs and a standard deviation of 120 kgs. So there are 430 adult female giraffes in the particular game reserve. Find the number of these adult female giraffes which can be expected to weigh less than 700. So I want the probability that they weigh less than 700. So I want where my x is less than 700. Okay, now that's not standard because I do not have such big values on the graph. So the first thing I have to do is standardize. So to standardize, I'm going to take the probability for my z less than, now I'm going to take my x value of 700 minus the mean, which I'm told is 830, divided by the standard deviation of 120. Okay, so that would give me a z value of negative 1.083. Okay, because we were told we need to find the number of the adults that are less than that. Okay, the first thing we need is this probability, because then I can take the probability that I have, because that's the proportion, and then multiply it by the total number to get the proportion and that number that are going to be less than. So now I've got my z value. So now I need to put that on my curve. So to draw my curve, I've got a negative value, so it's going to be on this side. So I've got negative 1.083, and I want everything less than, which means it's going to be everything over here. Okay, and now I know I can't have negative. Okay, so I have to flip the curve over. So to flip the curve, it means now it's going to fall on that side and I want everything there, which means the area is now going to the right. So to get all that information to the left that I don't want, I'm going to say 1 minus my value. Okay, in order to find my probability. So now I know what I'm looking for. So now 1 minus, now I look up 1.083 on the curve. So 1.0, I find my line, 8, I'm looking over there, and 3 from the last column means I'm going to add 7 to my 599. So if I add 7 to that, I end up with 0.8606. So on my answer, I say 0.8606. And when I type that in my calculator, my final answer is 0.1394. So this is the proportion of the giraffes that is less than 700. But now I wanted the number of them. So now I need to say the 430 in total times my proportion that is less than that to get my final answer of 59.9, which you can round off to 60. Okay, so that is another kind of question they can get. But remember, you always first have to get the probability before you can get a solid number. Okay, so if we look at another example. So here I've got The length of female snakes of a particular species are normally distributed with a mean of 54 and a standard deviation of 6.1. So now find the probability that a randomly chosen female snake of this species has the length between 50 and 60. So, first thing I'm told is I'm finding the probability of my x variable. Okay, it must be between 50 and 60. So that means it must be greater than 50 and less than 60. Okay, so now I've got to standardize those. So that is the same as saying my z value. I'm going to say the 50 minus the mean, and the mean is now 54, divided by standard deviation of 6.1. And the other side is now going to be 60 minus 54 over 6.1. So now, when I type that into my calculator, I get an answer okay, for the one side and for the other. So now I need to figure out that they're standardized, and now I got to draw my curve because now I need to figure out what am I actually going to calculate. So I've got a negative 0.6 and I've got a positive 0.9, which means I want everything in between. So now remember, when I want everything in between, I take the positive number that I'm going to want to look up on the table. Okay. And that's going to give me everything to the left. But now I want to subtract just that little bit. So just that little bit. If I flip the curve over to give me the positive side, I would have then said 1 minus. So I'm going to subtract that area I don't want, which is then going to be 1 minus my phi value to look up on the table. Okay, so now if I look up my first value, I've got my 0.9836. So 0.9, then I find 8 to get that value. And then my next one was 3, 6. So I could round that off to 4. Okay. And then I look up, that 4 says add 10. So now I add 10 to the last two digits. So I end up with 0.8375. So there I've got 0.8375 minus 1 minus, and now I look up 0.6557. So now I say 0.6, and I look along that one, find 5 to be finding my 0.422. And then my last two digits are 5, 7. Okay, so I can round it off to 6. And then I look up 6, as says add 19. So I add 19 to my last two digits. So 22 plus 19, okay, is going to give me 41. So I've got 0.7441. So there I say minus 0.7441. And when I type that in my calculator, I get my final answer of 0.582. Okay, so that's when we're dealing with things that are in between. So then, another example. I've got, in a certain town, the time X hours for which people watch television in a week has a normal distribution with a mean of 15.8 hours and a standard deviation of 4.2. find the probability that a randomly chosen person from this town watches television for less than 21 hours in a week. So I want the probability for my variable x, and it's for less than 21 hours. So it's going to be less than 21. So now it's not standardized. So the first thing I'm going to do is say my z value is now going to be less than 21 minus the mean divided by the standard deviation. And when I type that into my calculator, I get my z value. Okay, so now that I've got my value, now I can put that on my curve to know what I'm looking at. So I've got a positive value, so it's going to fall on this side. And I've got 1.238, okay? And I want everything less than, which means it's going to be everything over here. So now it's positive, and I want the area to the left, which means that I can read off my value straight as it is on the curve. So then I look on my curve, and I'm looking for 1.238. So 8 says add 15. So now I add 15 to my last 2 digits, okay, to get my final answer. And I will find that the value that I looked up is 0.892 for my final probability. Okay, and then if I look at just one more example for standardizing to find a probability, here I've got the times taken to swim 100 meters by members of a large swimming club having a normal distribution with a mean of 62 seconds and a standard deviation of 5 seconds. So now I need to find the probability that a randomly chosen member of the club takes between 56 and 66 seconds to swim 100 meters. So that means that I want, for my x value, because it's between 56 and 66, means it's got to be greater than 56 and less than 66. Okay, so now to standardize, for my z value, it's going to mean I'm going to take the 56 minus the mean of 62 divided by standard deviation of 5. Then I'm going to do the same thing on the other side. 66 minus 62 divided by 5. Okay, so now once they're standardized, I end up with my 1.2 and 0.8. So now I have my values. So now I can have a look at what that means on the curve. So it's negative 1.2 and positive 0.8. So I want greater than and less than. So everything in the middle. So now remember, when it's between positives and negatives, I start with the positive one and I look up that on the table. And then I want to then remove just that part on the negative side. So I would have flipped the curve and I would have said 1 minus. So I'm going to say minus my 1 minus just that part from the negative of 1.2. So now I look up 0.8 on the table. So I find my 0.80 to get 0.7881 minus 1 minus my 1.2 on the table. So 1.20 is there at 0.80. 0.8849. So then I say minus 0.8849. And when I type that in my calculator, I get my final answer. Okay, so that's how we standardize our variable, and then we find probabilities.